Hello, and thank you so much for joining me for video 2 from Module 1. So in Module 1 this week we are talking about psychology as a science, and in this particular video our topic is going to be exploring natural flaws in thinking, or the limitations of human intuition. Okay, so before we start talking about the limitations of human intuition as compared to scientific inquiry or the scientific method, it's important to understand what we mean when we talk about heuristics and biases. So essentially, heuristics are mental shortcuts that we all use to reduce the processing burden on our cognitive systems. Right? So if you think about it, we are constantly bombarded in our lives with information from all sorts of different sources in our environment. So we're constantly being assaulted by various stimuli, right? And we have to use that stimuli to make a lot of different decisions. Right? So if we didn't have some kind of shortcut or some kind of method of reducing the amount of work that we had to do to parse through all of that information, it would be very, very difficult to do the kinds of complex cognition that characterizes humans. So these mental shortcuts, our heuristics, are going to allow for much faster decision making, and it's going to require far fewer cognitive resources, right? So right away that solves the problems I just talked about, and most of the time those mental shortcuts are going to lead you to the correct decision or the right answer. But sometimes heuristics are effective, again, by virtue of the fact that they ignore or omit some information in favor of other information. And so because heuristics operate by not giving us the full picture all the time, that can sometimes result in errors in decision making, or what we call biased conclusions. Okay, so what we're going to talk about for the remainder of this video are situations where heuristics or mental shortcuts lead us astray or lead us to the wrong answer by biasing our conclusions. Okay, so arguably one of the most famous heuristics or mental shortcuts that biases our conclusions is something called the availability heuristic. So the availability heuristic is a cognitive bias where a person assumes that events that are easiest to recall are those that occur most frequently or most often. So you might imagine that people would use experience to decide whether to listen to the advice of weather forecasters or not, right? So let's say you live in Florida or some place where there's a lot of hurricanes, right? Well, it might be the case that you have a very detailed, rich memory of the last hurricane that occurred in your area of Florida. And it just so happens that that last hurricane that you recall didn't do a lot of damage, right? And maybe it was not just the last hurricane that you experienced, but the one before that and the one before that as well, right? So in this case, because you don't have any difficulty recalling instances where weather forecasters said that the hurricane was going to be really severe and do a lot of damage, but in actuality it did not, right? Because you have a very clear memory of that being the case, right? The availability heuristic might bias you to conclude erroneously that this most recent hurricane is nothing to worry about, right? And so therefore, because you can remember these instances where you didn't have to be afraid of a hurricane, right? You make the wrong decision, and maybe you choose not to evacuate, even in a potentially dangerous situation, right? So here, the availability heuristic, because you can remember lots of instances where hurricanes weren't as dangerous as the weather forecasters predicted, you decide not to evacuate, okay? And maybe, right, the hurricane that you thought wasn't going to be so dangerous does end up being dangerous, right? So this is a very clear illustration of situations where a mental shortcut whereby you rely on your memory, your most recent memories, to inform your decisions actually leads you to a wrong and potentially dangerous conclusion. And here's the what I would call the classic demonstration of the availability heuristic. So this was an experiment conducted by Lichtenstein and colleagues in 1978. And essentially what this table shows is the result of experiments in which participants were asked to judge the relative prevalence of various causes of death, right? So for each pair listed, the more likely cause of death is shown in the left column, right? And the number in parentheses indicates the relative frequency of the more likely cause of death compared to the less likely cause, right? So for example, 20 times more people die of homicide than die of appendicitis. Okay, so the number on the right indicates the percentage of participants who picked this less likely alternative, right? So for example, 9% of participants thought it was more likely that a person would die from an appendicitis than as a result of homicide. And in this case, therefore, the majority of people, or 91% of participants, correctly picked homicide as the more likely cause of death, right? So that's one instance where people successfully concluded that the more likely cause was actually more likely, right? But in many cases, for many of the other causes of death, a substantial portion of participants misjudged the relative likelihood, right? So essentially what people did is they assumed that the more likely cause of death were causes that tended to be publicized by the media, right? So for example, 58% of participants thought that more deaths were caused by tornadoes than by asthma, right? When in reality, 20 times more people die from asthma attacks than tornadoes, right? And even more striking is the finding that 41% of participants thought that botulism caused more deaths than asthma, even though in actuality, 920 times more people die from asthma than botulism, right? So what is happening here? Well, it's essentially the fact that these causes of death are often front page news, right? So when somebody dies in a tornado, there's all sorts of media generated where you can see, collapsed houses and it just receives a lot of attention by various news outlets, right? And so because of that, because these causes of death like tornadoes and botulism receive a lot of media attention, people tend to have very rich, very elaborate memories of people succumbing to these deaths. And because their most recent or most elaborate memories are informing their assessments of probability, Okay, they're going to assume that people are more likely to die from memorable causes, right? So events that are more easily remembered are judged as being more probable than events that are less easily remembered. Okay, so here's another example. I have two more examples of the availability heuristic applied to a slightly different scenario or a slightly different context. So in this particular experiment, Schwarz et al. Asked participants to answer the question, how often have you been assertive? Right? So think back about how many times you considered yourself to have been assertive. And in one condition, people had to come up with 6 examples, and in another condition, they had to come up with 12 examples. And then they were asked to rate their assertiveness on a 5-point scale, right? So 1 is, not assertive, and 5 is very assertive. And what they found is that, ironically, people who were asked to generate only 6 examples rated themselves as being more assertive than people who had to generate twice as many examples, right? So people who had to generate a smaller number of examples of assertiveness actually considered themselves more assertive. So what's going on here is, again, the availability heuristic. So because it is easier to come up with just 6 examples than 12 examples, right? People have to really work hard to come up with 12 examples. That's a lot of examples. So because 6 examples came to mind easier than 12 examples, people attributed that to them being more assertive. So again, the ease with which we are able to remember specific instances, right, is going to determine how probable we think something is, right? One more kind of similar example. So in this experiment by Fox in 2006, participants were asked to list 2 ways in which a course could be improved, right? So these were university students, and in one case they were asked to come up with just 2 ways in which their psychology course could be improved, or 10 ways in which a course could be improved. So just like the previous example, right, coming up with 10 potential improvements is going to be a lot harder, at least one would hope, than coming up with just 2 improvements. And then participants in both conditions were asked to give an overall rating for the course. And again, we see that people who had to list 10 ways as opposed to 2 ways gave a higher rating of the course, right? And why is this? It's because they really had to struggle to come up with 10 criticisms, right? That information didn't readily come to mind. And so because it was harder for them to think of instances where the course could be improved, they presumed that the course must have been a fairly good course, right? Okay, so once again, the ease with which information comes to mind influences subsequent judgments. In this case, your judgments about the quality of a particular college class. Okay, so now that we have talked about the availability heuristic, let's talk about another very thoroughly researched heuristic. So the representative heuristic is a cognitive bias where the outcome predicted is based on how similar an event is to a typical example of that event, right? So I have a couple of examples here. So I'm sure many of you can relate to all of the stress that is plaguing our society right now regarding our general health and wellness, right? Particularly in light of the coronavirus pandemic. So a lot of what gets circulated on Facebook and other social media and mass media platforms is information about how to stay healthy, right? So one of the most important health decisions we can all make is the decision about what we're going to eat, right? So a lot of people, in making the decision to eat healthier, right, end up choosing foods that they think look like what they assume are healthy foods, right? So you choose to eat a particular food because you think it most closely resembles the category or schema that we all have for healthy foods, right? So what do I mean by that? Well, think about any fast food restaurant that you go to. So it could be something more kind of high end like Chipotle or even just, McDonald's. They always have items on the menu that are associated with certain buzzwords, right? So for example, if you see a salad or chicken, you might see words like cage-free or whole grain or free range, things like that. And the reason why restaurants do that is because these words are associated with a certain image. The same thing with words like organic, for example, preservative-free, GMO-free, right? So all of those words kind of bring to mind images of health, right? But when we actually look at, for example, the nutrition facts in a salad we might purchase at McDonald's, right? The salad always looks very fresh and healthy, right? The tomatoes are always bright red. The cucumbers are, at least look like they're nice and crispy, right? But if you look at the actual nutrition facts and see, for example, how many grams of fat there are in the salad dressing, it very quickly becomes apparent that it might not actually meet some of those health standards that your physician or dietitian might recommend, right? So all of that is to say, items that we assume meet criteria for fitting a particular schema might not actually be representative of that schema, right? Another example, we might, in seeing an image of someone wearing glasses, particularly thick glasses, we might assume that that person is more intelligent as compared to someone who is not wearing glasses, right? And that's because when we think about our prototypical intelligent person, that person is often wearing glasses, right? But in actuality, there is no association between needing corrective eyewear and intelligence, right? That's an entirely spurious correlation. So just because something seems to resemble our categorical understanding for something doesn't mean that it actually reflects whatever that outcome is. So let's look at some more examples of experiments. So let's say we randomly pick one male from the population of the United States. That male, Robert, wears glasses, speaks quietly, and reads a lot. Is it more likely that Robert is a librarian or a farmer? Okay, so just go ahead and think about that for a second. Is Robert more likely to be a librarian or a farmer? out when psychologists actually gave participants this problem. A significant proportion of them chose a librarian or assumed that the description they were given more closely matched that of a librarian. Right? So the description of Robert as wearing glasses, speaking quietly, and reading a lot matched participants' image of a typical librarian. Thus, they were influenced by the representative characteristic into basing their judgment on how closely they think the characteristics used to describe Robert describe a typical librarian. Right? Unfortunately, however, just like with a lot of heuristics, they were ignoring an important source of information. And that source of information was something called the base rate. Right? So the base rate is the relative proportion of different classes of people in the population. Right? So a base rate is what percentage of the all of the males in the United States are librarians, and what percentage of all the males in the United States are farmers, right? So in 1972, when this experiment was first carried out, there were many, many more male farmers than male librarians in the US, right? So if we look at the proportion of individuals who are farmers and librarians in the US, it's much, much more likely that Robert, if we were to simply pull him randomly from the population, it's much more likely that Robert is a farmer. And in fact, this base rate still holds today. So even today in 2020, if we were to randomly select a male from the population, it is significantly more probable that he would be a farmer as opposed to a librarian, right? So essentially what's happening in this problem is, again, people are thinking about what characteristics they would typically ascribe to a librarian, and if the description provided resembles those characteristics, then they assume that that particular outcome is more likely. But they fail to consider, in this case, the probability or the base rate associated with that particular outcome. So one reaction to the farmer-librarian problem might be that perhaps the participants were not aware of the base rates for farmers and librarians, so they didn't have the information that was necessary to make the correct judgment, right? So the effect of knowing the base rate has been demonstrated by presenting participants with the following problem. So it says in a group of 100 people, there are 70 lawyers and 30 engineers. What is the chance that if we pick one person from the group at random, that person will be an engineer, right? So participants given this problem correctly guessed that there would be a 30% chance of picking an engineer, right? However, for some participants, the following description of the person who was picked was added, right? So in addition to the top description, participants were given this scenario, which says, Jack is a 45-year-old man. He is married and has 4 children. He is generally conservative, careful, and ambitious. He shows no interest in political and social issues and spends most of his free time on his many hobbies, which include home carpentry, sailing, and mathematical puzzles. Right? So adding this description causes many participants to greatly increase their estimate of the chances that the randomly picked person, Jack in this case, was an engineer, right? So apparently, when we only have information about the base rate available, we're going to correctly use this information to make our judgments, right? However, when we are given any descriptive information at all, right, we're very likely to disregard the base rate information in favor of the descriptive information, right? And it's this reliance on the descriptive information that causes errors in our judgments. Okay, so let's look at another problem. So this is another very famous problem. And it says, Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy as a student and was deeply concerned about issues of discrimination and social justice, and she also participated in anti-nuclear demonstrations. Which of the following alternatives is more probable? Number 1, Linda is a bank teller. Or number 2, Linda is a bank teller and active in the feminist movement, right? So go ahead and pause the video and think to yourself for a second, which of these two alternatives do you think is the more probable alternative? So the correct answer to this problem is that statement 1 has a greater probability of being true. But interestingly, when Tversky and Kahneman posed this problem to their participants in 1983, 85% picked statement 2, right? And it's kind of easy to see why they did this, right? They were influenced by the representative heuristic because the description of Linda fits with a lot of people's ideas of what a typical feminist does, right? However, in choosing statement 2 and assuming that Linda was both a bank teller and a feminist, they violated what's known as the conjunction rule. So the conjunction rule states that the probability of two events, or the probability of A and B occurring, cannot be higher than the probability of a single event. So the probability of A and B occurring together can't be higher than the probability of A occurring alone or B occurring alone, right? So, for example, the probability that Anne has a red Corvette cannot be higher than the probability that she has a Corvette. Why is that? Well, it's because these events together, having a Corvette and having a red Corvette, define a smaller number of cars than any single event, right? So the pool of cars that satisfy the requirements of being a Corvette and red is going to be smaller than the pool of cars that satisfies, the constituent of being a Corvette alone, right? And similarly, there are more bank tellers in the world than feminist bank tellers, right? So stating that Linda is a bank teller includes the possibility that she is a feminist bank teller, right? So again, what's happening here, just like with the previous examples, is people are demonstrating a poor understanding of probability, right? So when you don't take into account the base rate, that's an example of a misunderstanding or a lack of paying attention to probability, just like the Linda problem, right? Not realizing that the probability of being a feminist bank teller is smaller than the probability of being a bank teller if we were to choose any person at random is an example of a misunderstanding of the conjunction rule and thereby a misunderstanding of probability. Right? And again, people did this because they saw Linda's characteristics as being more representative of parsimonious bank teller than bank teller without taking into account the probability of those events. Okay, so I'm going to show you a couple more examples of people demonstrating a lack of understanding about probability. So people tend to believe that they are above average in socially desirable qualities, such as driving, kissing, and telling jokes, right? So a whole range of, of desirable qualities. People assume that they're above average as compared to other people, right? So, for example, most undergraduates believe they will graduate and earn a better than average income and live in a better than average home, even though by definition only half of the people in the world actually end up doing so, right? So again, people have an inflated estimate of the probability that they will achieve highly desirable outcomes, right? So we tend to overestimate our own skills, abilities, and performance when comparing ourselves to others without taking into account the actual probability of achieving those things in the population. So kind of an interesting caveat for this better than average effect is that in general, people think that they are better than their average peers. But in one particular study, researchers wanted to see if that remains true at any age. So what they did is they separated their participants by age, creating 3 groups. And these groups included young people between the ages of 18 and 39, middle-aged people between the ages of 40 and 59, and an older adult group between the ages of 60 and 85. And what the researchers wanted to see is if each group felt that they were better than average on a variety of traits and abilities, right? So just consistent with the previous slide, most of the time, each age group displayed the better than average effect. Okay? So for almost all of the traits, people thought they were better than average. However, in areas in which older adults tend to decline, right? So in areas where older adults have age-related declines, such as athleticism, for example, or physical attractiveness, they reported being worse than their average peers. Okay? So it seems like at some point, as we age, we come to accept our limitations relative to our younger counterparts. Whereas this doesn't happen with younger people, right? So young adults and even middle-aged people still thought they were better than average on these characteristics. So older adults were the only ones that really were able to do kind of a more honest or more realistic appraisal of themselves, right? So the better than average effect persists for all age groups, but older adults rate themselves below average on physical attractiveness and athleticism. Okay, so continuing with our discussion of different biases and heuristics that people fall victim to. One of the things that we psychologists encounter by non-psychologists is this general notion that the findings of psychological science, right, or the research findings that psychologists are responsible for tend to be kind of obvious, right? So people tend to, one of the reasons why people think of psychology as a soft science rather than a hard science is because they assume that the insights that psychologists offer into various aspects of human behavior and mental processes are predictable, right? So how do I know this? Well, this is an example of an article that was published in a scientific journal, right? So the title of the article is Experimental Pre-Testing of Hand Washing Interventions in a Natural Setting. Okay, so that's how the article appeared in the scientific journal. And here is how it was described in the press. Okay, so this was a popular press article, and it says, science confirms the obvious, people wash their hands more when they're watched. Okay, so again, people are assuming we didn't need an experiment to tell us that people are more likely to wash their hands in the presence of others, right? So just at first blush, having read probably the abstract of that article, they assume that psychology didn't have anything really valuable to offer in their investigation of this topic. But let's look at this experiment a little bit closer. So what it actually was were psychologists put wireless sensors that measured the entry of individuals into restrooms. And they also monitored soap dispenser use, right? So essentially what people were trying to indirectly measure, so people weren't actually watching them, but they were trying to determine hand washing behavior after people use the restroom. And so in addition to looking at through these wireless sensors, whether people were washing their hands or not, there was the primary thing that was manipulated was the message that appeared over the sink. Okay, so there was an electronic billboard, if you will, above the sinks that were displayed in the restroom. And they displayed either nothing, so that was one of the control conditions, or one of many different types of text messages. Okay, so one of the messages that would appear on this little billboard that as people approach the sink was a message designed to elicit disgust. Okay, so this message might be something like soap it off or eat it later. Right, so that's designed to elicit disgust. Or it might be something that was designed to simply activate knowledge, right? So for example, wash your hands thoroughly with soap, right? So that's just kind of a reminder or a prompt, if you will, designed to activate knowledge. Okay, so now that we know what the experiment actually intended, what the method was, let's talk about the results. So what they found is that men were more likely to engage in hand washing behavior when the message was designed to elicit disgust, whereas women were more likely to wash their hands for if they viewed the message designed to activate knowledge, right? So right away, right, it becomes clear that the actual experiment that was conducted by these researchers was far more complex than was described in the press, right? So it wasn't just that people wash their hands more likely to wash their hands when they're watched, which by the way they weren't even actually watched, but it was much more nuanced than that. So we see a really interesting effect of gender here that I think it's safe to say would have been difficult to predict from the outset. So there's a tendency to think after you know about the results of an experiment that you would have been able to predict it beforehand, right? But in this case in particular, I think these results are interesting or complex enough that it's not likely that they would have been predicted from the outset. Here's another example, swearing as a response to pain, right? So this is another one that was featured prominently in the press. So essentially what the study was investigating is whether swearing affects pain tolerance, right? But remember, when we conduct experiments in the lab, we are required to do so ethically, right? So it's not like we can just, hit people in the head with a 2x4 and see whether it hurts or not, right? So we have to operate within some ethical constraints, right? So one of the ethical ways that we can elicit the experience of pain in the laboratory is to have people immerse their hand in very, very cold, icy water, right? So if you've never done that before, if you've never submerged yourself in very, very cold water, if you're not a polar bear or one of those people that likes to do that, it's very, very painful, okay? But there's actually not any permanent damage, right? So you can't actually have any tissue damage or anything permanent as a result of that, as long as you're not submerged for days and days and days. So that's kind of the workaround as far as studying pain in the laboratory, is if it's temporary and you're not actually damaging any tissues, it's considered acceptable. So what they were looking at is how long people could withstand pain, so how long they could keep their hands submerged in the ice water, and also their perception of the pain, and other sort of physiological measures like heart rate. Okay? So essentially what they did is they looked at all three of those variables, and in one condition, people were prompted to repeat a neutral word. Okay, so it's a word without any sort of emotional content or valence to it, or to repeat a swear word. Okay? So what they found is that swearing increased pain tolerance. So people were able to hold their hand under the ice water for a longer period of time. It increased heart rate, okay, so there was more physiological activity, and it decreased perceived pain compared with not swearing. Okay, so swearing seemed to have an analgesic or pain relieving effect. Okay, however, swearing did not have this analgesic or pain reducing effect on males with a particular tendency to experience anxiety. So males who tended in particular to do what's called catastrophizing did not experience the protective effects of swearing. So catastrophizing basically just means ruminating about the worst possible outcome, right? So experiencing anxiety and imagining the worst possible scenario. So those males in particular did not experience that benefit of swearing, right? And so the theory proposed by these researchers is that the pain lessening effects of swearing are caused by the fact that it induces a fight or flight response. Okay, and one of the resultant effects of having an engaged fight or flight is that you're less likely to experience pain. Okay, so again, this is an example of a psychological study that gave us all kinds of information, right? So it wasn't just that swearing is an effective strategy for dealing with pain, right? But it's a profile of who is more likely to experience those benefits, and also why those benefits occur, right? So again, it's not very likely even though it might seem obvious to you, having heard the results of the study, it's very unlikely that if I had asked you prior to presenting these results what the outcome would be, that you would come up with the kind of nuanced information that the researchers did. So why did I give you these examples? Well, both of these examples are examples of something called hindsight bias. So hindsight bias is a cognitive bias in which a person feels that they predicted the outcome of an event when they did not, right? Or that they could have predicted the outcome of an event when they could not have, right? So it's known as the I knew it all along effect. Okay? And another just, excuse me, very simple example of hindsight bias or the I knew it all along effect is smoking or tobacco use, right? So any of you who are even just a little bit familiar with American history, you know that we have been using tobacco products basically since the colonial times, right? And so for many years, smoking and tobacco use was a pastime that was very, very prevalent in our history. However, eventually, science kind of caught up, if you will, and it was revealed all of the deleterious consequences of smoking. So the fact that many of the chemicals in tobacco products are carcinogens and can cause cancer and tooth loss and all sorts of really negative health consequences. Eventually, we became apprised of that. So much so that there's now a Surgeon General's warning on all tobacco products, right? However, interestingly, when this information was first disseminated to the public, so when the United States decided to issue this Surgeon General's warning, communicating this to the public, there was an overwhelming tendency from individuals at that time to say, oh, well, I always knew smoking was bad for you, right? And similarly, people will often say that today about the supposed consequences of vaping, right? Is I could have told you that that was bad for you. I knew that was bad, you know. That's why I never use the stuff, you know. But in actuality, if we look at society's behavior at that time in the 50s and 60s and 70s, cigarettes were everywhere, right? On all of the TV shows, if you've ever seen an episode of I Love Lucy or Leave It to Beaver, there's you know, the kind of quintessential father figure sitting in the chair smoking a pipe. And at one point, they were actually marketing tobacco products to children, right? So it's very, very unlikely, and there's in fact no evidence to support the claim that the majority of the public were in any way aware of the negative consequences of smoking prior to the Surgeon General's warning, right? So as much as people wanted to say, oh, I could have predicted that, I always knew it was bad for you, there's no evidence that society was that informed prior to that time. Okay? All right, so that's the hindsight bias effect. So just a couple more biases left that I want to go through with you guys. One is one that should be familiar to you, the confirmation bias. So the confirmation bias is when we only look for evidence that confirms what we already believe, thereby strengthening the original belief, right? So this is kind of a silly example, but let's say that one of your favorite pastimes is telling jokes, right? So you like to be funny, you like to joke around. And you take a lot of pride in the fact that you're funny, that you're a jokester, right? So if one of the core features of your personality, right, to yourself is that you're funny, it's very likely that you are going to seek out information that confirms that, right? So if you think that you're a funny person and you place a lot of value and self-worth on that identity, right, you're more likely to remember all of the times that your jokes were well received, right? So all the times that you made people laugh, as opposed to maybe some of the times where your jokes fell flat, right? Maybe they were awkward, maybe they made people angry, what have you, right? But because you're invested in your identity as a funny person, right, you're going to seek out preferentially those instances where you were funny. Similarly, psychologists can fall victim to the confirmation bias as well very easily. So if you are a psychologist studying physical violence, right, you might believe that violence is a product of environment, right? So you might believe that early childhood experiences like abuse from a family member are the best predictors of future violence, right? So if that's your orientation, you are going to be more likely to look for papers, right, or look for scientific evidence that confirms that hypothesis. As opposed to a psychologist who maybe studies biopsychology and genetics, right? Someone with that orientation might believe that it all comes down to genetics, right? It all comes down to things like testosterone or things in your physical makeup that predispose you to violence, right? So maybe if you have an overactive amygdala or high levels of testosterone, maybe those are better predictors of violence than environment. Or maybe those override environment. The fact is, both of those are predictors of future violence, but if you place more value on one than the other, you're more likely to seek out science that confirms that. Relatedly, there's something called belief perseverance. So belief perseverance is going to essentially means that you maintain a belief and continue to espouse that belief despite encountering contradictory factual information, right? So even when you encounter information that is directly contrary to your belief, okay, you continue to maintain that belief, and you often maintain that belief by interpreting the contradictory information in a way that does not invalidate the original belief. Okay? So with the confirmation bias, you're seeking out confirming information for yourself. With belief perseverance, your belief does not change even when the evidence that you find contradicts your position, right? So, for example, a person, for example, who thinks that climate change is not a significant problem facing our country today, right? If they're firmly invested in that belief, they continue to maintain it despite being given evidence, scientific evidence to the contrary, right? Similarly, if you have a friend who maybe spreads lies about you on Facebook, but you continue to believe that friend is a good person despite evidence that they are not a good person, right? So that's a lot of times how abusive relationships continue, as when victims of abuse kind of continually discredit or deny mounting evidence that the person they're partnered with is destructive in some way. Right? So continuing to maintain a belief that is destructive or problematic, even when you're given evidence to refute that belief. Okay, and the last bias or heuristic that I want to talk about is the Myside bias. So the Myside bias is just the tendency to rate arguments consistent with your beliefs more favorably than you rate arguments that contradict your beliefs. So the best way to explain that, the Myside bias, is to give you another example of an experiment. Okay? So a really famous experiment was conducted by Lord and colleagues. So essentially what they did is, by means of a questionnaire, they identified one group of participants in favor of capital punishment and another group of participants who were opposed to capital punishment, right? And each participant was then presented with descriptions of research studies on capital punishment. Okay? So some of the descriptions provided evidence that capital punishment had a deterrent effect on murder, right? So that would be examples of the potential benefits of capital punishment. And other descriptions provided evidence that capital punishment was not an effective deterrent, right? So they saw descriptions of evidence that either opposed or were in favor of capital punishment. So when the participants reacted to the study descriptions, their responses tended to reflect the attitudes they had at the beginning of the experiment, right? So we see right there kind of confirmation bias in effect, right? People tended to, or both confirmation bias and belief perseverance, right? So people tended to continue to espouse the same beliefs they had at the beginning of the experiment. And these beliefs persisted even in the face of contradictory evidence. But interestingly, with respect to the Myside bias, right, they gave different appraisals of the descriptions depending upon their belief, right? So for example, an article presenting evidence that supported the benefits of capital punishment was rated as convincing by proponents of capital punishment and unconvincing by those against capital punishment. Right? So again, this is confirmation bias. People's prior belief caused them to focus only on information that agreed with their beliefs and to disregard information that doesn't. And they also, along with that, tended to rate arguments consistent with their beliefs as being more favorable or more convincing than arguments that contradicted their beliefs, which is the Myside bias. Okay guys, so this video is almost at 1 whole hour and I apologize. I promise that my other videos, I will do everything I can to make them a little bit shorter, but hopefully you found this video interesting, and I will talk to you in my next video, and I hope you have a great day.